Okay, you guys, we're on page 106 to start today. We're going to continue to talk about point slope forms. So we're going to see exactly the same stuff that we saw yesterday to start off. So this should be familiar. So on page 106, our first example, we're starting with an equation. We want to identify some key information from our equation and then make a graph in a table. Okay, so what point do I get from this equation? 1, 4. Yeah, it comes from here and here. Remember, opposite sign on that x value. 1, 4. And then what's our slope? -2. Very good. Slope is right in front, -2. Since I have a point and a slope, I can create a graph for this. So I'm going to plot my point, 1, 4. And then remember, slope is rise over run. I don't see anything on bottom, if we want to call it that, on bottom here. Yeah, that means that it's a 1. And then remember, since our slope is negative, that means our rise is going down. So this would be 1, 4. I'm going to go down 2, forward 1, down 2, forward 1, down 2, forward 1. If you want some points to the left, remember you can reverse your slope directions, up 2, back 1 to get some more points. What's the minimum number of points I want to see on your graph? 3. Always at least 3. And then since we're graphing a function, don't forget to connect your points and throw your arrows on the end. Remember, for your table, you can always select values of x to plug into your function, but since I've got a bunch of points here, I'm just going to pull points from my graph to throw into my table. So we've got 0, 5, that's my y-intercept right there. And then 1, 4. That's a one to definitely make sure I identify because it's the point that they gave me from the function. Then I've got, looks like 2, 2. Oh, 0, 5. This is 0, 6. Sorry, you guys. Did that last hour too. We're right above 5. 0, 6 for that y-intercept. My x-intercept is 3, 0. And then I've got the point 4, -2 on here as well. Questions for me on that first one? Okay, try the second example on page 106. This time you're given a point and the slope. I want an equation, a table, and a graph. Well, we know it's not any of you guys because you're in here. I'm going to start with my equation. This would be y equals -1 times x plus 2 plus 0. Do I have to write the plus 0 at the end? No, when we're just adding 0, we actually don't have to include that. So this would also be point slope form. Now let's go ahead and graph. So I've got a point. So we're through the point -2, 0. That's right here. That's my x-intercept for this graph. And then my slope is -1. So I'm going to go down 1, forward 1. Down 1, forward 1, down 1, forward 1. There's my y-intercept. Down 1, forward 1. Remember, minimum of 3 points. And then connect your points and throw your arrows on the end. I'm going to go ahead and throw some of these points into my table. So I've got the point -2, 0, which they gave me. I've got -1, -1. I've got 0, -2, 1, -3, 2, -4. Questions on that one? Okay, turn to the next page for me. This time on page 107, we're starting with a table. If I have a table to begin with, what might be a good first step? Do what? Yeah, I've got points here. Make a graph, right? I've got a bunch of points, put them on my graph. Now this first one is going to be off my table here. It's going to be way up here somewhere. So I'm not going to be able to plot that one, but I can plot the rest of these. -5, 7, -2, 2, 1, 1, 2, 3, and 4, 8. There's 7, 8 would be right about there. Okay. Always minimum of 3 points for your graph. Then connect them and draw your arrows. So we need a point and the slope to write our equation here. I'm just going to pick the top point from the table. You could pick any point that you like. And then I need the slope. What's my slope? Yeah, we're going down from one point to the next, so it's definitely going to be negative. I go down 1, 2, 3, 4, 5, and then over 1, 2, 3. -5 over 3. So then my equation would be y equals -5 over 3 times x plus 8. Remember opposite sign, and then plus 12. If you used a different point, these numbers would be different, but your slope would be the same. Questions for me on this one? Okay, just like what we did yesterday, right? Same format and everything. Try the last example on page 107. Try this guy. Starting with a graph this time. Okay, let's take a look at this guy. For our graph, we've got 2 points that they bolded for us, but we can pick out a couple others. I'm going to go ahead and throw these into my table to start. So I've got the point -4, -4, -1, -3, 2, -2, and 5, -1. I have one open space in my table. So after I write my equation, I'll fill in that last space in my table. Point, you have 4 options. Pick whichever one you want, okay? I'm going to select this guy. If you picked a different one, that's okay. So I'm going to choose the point -1, -3. And then for my slope, I'm going to count that from my graph. So our slope was up 1 over 1, 2, 3. We got 1/3 for our slope, yeah? Okay. So now my equation based on the point that I picked would be y equals 1/3 times x plus 1 minus 3. If you picked a different point, these two numbers here are going to be different. That's okay. And now the last thing I need to do is finish up my table. So I want to plug in a value for x, right? You can pick whatever value for x you want, but just like yesterday, where we had that sort of funky thing, I think it was 2/3 yesterday in the middle or in front for our slope. Depending on the x value we picked, we could get some weird y's. So you can, again, pick whatever x you want, but I'm going to try and pick an x that makes my arithmetic easier when I simplify. So since I'm multiplying by 1/3, remember that's going to be the same as dividing by 3. So I want to pick a number for x that when I add 1 is going to give me something easy to divide by 3. That's why 2 had a nice y value, since 2 plus 1 is 3. 5 had a nice y value, since 5 plus 1 is 6. So what might we want to pick for x here? Well, we have 2 already. 8 would be a good one. 8 plus 1 is 9, and we can divide 9 by 3. So I'm going to do that down here. So 1/3 times 8 plus 1 minus 3. 8 plus 1 is 9. 9 times 1/3 is the same as 9 divided by 3. 9 divided by 3 is 3. And 3 minus 3 is 0. So our last point would be out here somewhere, 8, 0. Questions for me on this last one? Okay. The last thing I want to talk about in your packet for today is on the next page. Turn the page for me. I want to revisit a couple of the word problems that we've seen so far, but look at them through this point slope context that we've been talking about. So number 1, we've got a climber on a hike. We've seen this example before, but when we saw it before, they gave us 2 different points. So it's telling us here, after 6 hours, he's at an altitude of 700 feet. So they gave us that, and then they gave us, like, after 7 hours, he's at an altitude of whatever. And we used that to find the slope when we saw this problem before. Here, we're going to write an equation for his progress, for his travel, using the information that we're given. And based on the information, we'll use point slope form. So it says after 6 hours, he's at an altitude of 700 feet. That's a point. 6, 700. He has an average hiking pace of 75 feet per hour. That's a slope. Right? This is a rate of change here. Every hour he's hiking 75 feet. So write an equation that models his altitude in terms of the time that he's been hiking. So my equation, altitude in terms of the time, would be our slope at 75 times, we're using t for our variable here, so t minus our time value, that's 6, plus our altitude value, that's 700. There's an equation for Cliff's progress using point slope form this time instead of slope intercept. Number 2, same idea. Sarah saves $12 of her allowance every week. If I'm doing something every week, that's a rate of change, right? When we did some practice with writing slope intercept form last week, we said that recurring value, the one that repeats, is our slope. And so every week I save $12, that's a repeating value. So my slope is 12. And then it says after 20 weeks, she has a total of $379. That's a point, 20, 379. Write an equation that models her account balance in terms of the weeks that she's been saving. one good thing to double check when I write my point, it says I want a function that models my account balance in terms of the weeks that I've been saving. So I want A of W. Make sure that your X coordinate, the thing that would go in the X spot, W is your W value. So that's weeks here. So A of W equals 12 times W minus 20 plus 379. Point slope form. Okay, and then our last one. To learn more about water evaporation, Bryce measures the depth of a puddle after a rainstorm. His first measurement was 2.25 inches, taken 3 hours after the storm. Bryce takes another measurement an hour later to determine the rate of evaporation of the puddle is 0.25 inches per hour. Write an equation that models the depth of the puddle in terms of T, the number of hours. So I'm going to have D of T. Okay. So the first information I get is a point. My first measurement was 3 hours after the storm. Now remember my sort of X value, my T is time. So when I set up my point, I want a time in the X spot. So 3, 2.25. And then my slope, they gave me that rate of evaporation for the puddle was 0.25. Now remember we're talking about evaporation. So what's happening to that depth of the puddle if the water is evaporating? It's going down, right? So we're going to have to put a negative right in front there. Okay. Our slope's negative because that water is going away when we evaporate. So then to finish my function, negative 0.25 times T minus 3 plus 2.25. If I don't have initial values, it's kind of hard to write slope-intercept form. But point slope, if I've got a value, if I've got some points, not too bad. The last thing I would like you to do for me, somewhere where you've got some space on your paper. So if you've got room up here or at the bottom of page 108 or at the bottom of page 107. Really quickly, just to finish off our work together for today, I'd like you to go through these last 3 examples. So give me a function, identify those key features, and then give me another function. Okay, check your work. My function for this first one would be y equals 2/3 times x minus 2 minus 3. For number 2, my slope is -2. The point I get from this equation would be -5, 2. And then for our last example here, write a function This would be y equals 6 times x minus 1 plus 0. You could leave off the plus 0 and still be correct here. Yes. It's always opposite of what we see in parentheses with x. So yesterday when we talked about those transformations, we said if I just asked you about the transformation, this would tell you to go to the left 5. So 1, 2, 3, 4, 5. And then this would tell you to go up 2. So you'd end up with the point -5, 2. Does that make sense? Okay. Any other questions for today? Okay, the last thing that we're going to do today is a quick check over point slope form. Okay, so go ahead and put away everything besides the writing utensil and we'll get started.